Okay, guys, so thank you for watching this video. So I wanna recall a little bit of this lecture number 2. All right, so remember the lectures are here, week 1 in Blackboard, right? Announcements. So last time we saw systems, basically how to solve a system of equations. This triangular example was important. And there is something interesting here. Oh, sorry, I'm not sharing my screen. Let me share my screen. Okay. So yeah, so I was showing you these slides. They are in the announcements, right? Week 1. So last time we were talking about how we're gonna change from solving lines to more than a line. That could be a set of lines or a set of planes, basically a set of equations. And they are called basically hyperplanes because they can be several dimensions. So I like this example just to mention something here. So like part of the review, let me write it over here and I can write back. Minus 5x3 plus dx4 equals 2. So I want to make sure you understand what is called triangular, right? I got x3 plus 2x4 equals minus 4 and x4 equals 5. Okay, so when we wrote the system in another way, so it can be written like this. We got x1 minus 2x2 minus 5x3 plus 3x4 equals 2, x2 plus 3x3 minus 4x4 equals 7, x3 plus 2x4 equals minus 4, and x4 equals 5. 2, 7, minus 4, 5. Okay, so so you can see this is a triangle, right? And if you make it bigger, if you complete the triangle, if that they usually how the system looks like as a rectangle, right? But what we're gonna do in the future, so this is spoiler alert for you, but there's a spoiler alert. You need to know to see what do you expect, okay? So in the future, we're gonna get tired of writing x1, x2, x3 all the time. So instead of doing that, we're basically gonna we're gonna make a column for x1, for x2, for x3, for x4. And instead of the equal, we're gonna put a line over here, and here we're gonna put the b's. So we're gonna put 1, minus 2, minus 5, 3, and 2. 1 minus 2 minus 5, 3, and 2. The next line, notice that I don't have anything over here. So that's gonna be a 0. The next, I'm not gonna write the x2. So I'm just gonna write a 1. So I just write the coefficients, right? Instead of writing plus 3x3, I write 3. Instead of writing minus 4x4, I write just minus 4. Then I write 7. The next one, so that's gonna be 0 and 0. So that's what I do, 0, 0. And then I got 1, 1x3, 2x4 is my b. And then finally, I have 0, 0, 0, because this is 0, 0, 0. Because I don't have any x1s, any x2s, any x3s. But I have one x4, and then this is a 5. So that's why it looks triangular. So you see is, look at this. This is a triangle, and you have these ones, okay? That's something I said that you guys, it's good that you guys come to watch these videos and you just don't go to read the book. For example, the last class, if you check the book, that's 50 pages. Just go and check it out. So this is the future, what I want to do in the future. But if you try to read the book and understand what is the correspondence and all that, it's just, you need to see an example. So it's better if somebody explains it to you, and then you read it, you say, oh, yeah, that's what he was saying. But if you try to do the opposite, it's going to be really hard. Trust me, I tried to do it, and it's confusing. Okay, so so there's another way to to see those matrices. In occasion, I'm going to have to stop the video, and so you have to be patient. I need to drink water. Okay, so we solved that last class. I'm not gonna go over that again. We talk about triangular matrices. We talk about echelon forms. And echelon form, this is basically what we want, okay? This is just a fancy way, echelon. And sorry, probably it's not the right pronunciation. I'm gonna have to look for it. Not echelon form. It's the last name, right? It's the last name of somebody. But basically, you have numbers and zeros below it. So, for example, if there is a number in this row, below that, this is the first number of that row. The next row must have a 0 there. You see, this is the first number of this row, so it has zeros over here. Number over here, 0 below that. So that's gonna be something we have to get used to see. Those are systems that are economical. They provide understanding. So it's like you reduce the noise, like not too much. It's like simplifying, remember? when you have algebra, you could have a fraction like 24/6. Well, what is that? That's just 4. So what do you prefer, 24/6 or 4? Or you have 236/140. So, you start simplifying this one, right? Until you get a better number. So, for example, half 70, right? Half 118. Half 59. Half 35. And probably that's it. So it's better to write 59/35 than 236/140. So echelon form, the idea is that we transform a matrix, and this is again the future. So it's spoiling alert, but in science, this is important. So we're gonna have matrices like 1, 3, 5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, or whatever. So let's say this is a matrix. There is a way to write this matrix in this form. So something try to be triangular. Okay. They're equivalent. Okay. So it's like a factorization. So the echelon form is going to be like the future factorization of a matrix. So, I don't like just to read the slide, and give you definition, like a robot without seeing the future. But in my previous video, when I was doing the video, my iPad froze, so I couldn't explain those things. So that's what I'm going over the lecture of last time. Okay, what else? And that was it. So I guess, yeah, I can go over the other slide. So far, I went to let me see, announcements, and the second part. So we also did these vectors things, and you had seen vectors from since you were in high school, because how do you express a force, right? So you have this mass, and you're pushing this mass in this direction. You need vectors, okay? So if something is falling, the gravity is pushing down. It's a vector force, right? 29 milligrams, whatever. Okay, so so those vectors you have been using. So what we're gonna do here, what we're gonna do here is establish vectors like numbers. We know the numbers we can add, subtract, and so on. So like 5 plus 3 is 8. 5 minus 3 is 2. Now you're gonna make sure you know this. Minus 5 minus 3, if minus 5 plus 3. So minus 5 minus 3 is minus 8. Minus 5 plus 3 is minus 2. So when you do these operations, you are moving in a real line. That's R. That's your vector space right there. Okay. So you can go, you move steps. You move 5 steps, you start at 0, and you move 1, 2, 3 steps, say, to the right? But then you can move 3 steps 5 values. So you finish here, -2. So you just have two directions to move. In vectors, let's say these are vectors on the real line. The numbers, real numbers, are vectors in the real line. However, you need more directions, right? Because this is good for when a car is moving to the right or to the left. Basically, less than that. Basically, you're pushing a mass in this direction or this direction, right? So you need to move to the right or to the left. You cannot move anywhere. But here, let's think this is a different scenario. So you are in a table. These are 2 dimensions. This is R2 now. R2D2. R2 is like it says over there. So you have a couple. Here, these numbers are just numbers, right? Like A belongs to the real numbers. Here, you have probably A and B belongs to the plane, to the vector space. And this is a plane, but this is a vector space too. Real numbers are really good. So as explained in the slides last time, if you want to graph A and B, this is x coordinate, y coordinate. So you go 2, 2, 2, 2, 2, and then you say this is my A. You go 2, 2, 2, 2, 2. This is my B, and this is your vector. A and B. But in the slides also show that A, since you can add uh, two numbers over here, you can add 2 vectors. Let's say this is A1 and A2. So you can add A1 plus A2. So here you need to add A1, B1, and A2, B2. So we need another vector. And some people cannot see red. So let me use another color. People usually don't complain about green. So, let's see this one. So let's say this is A2B2. So this is A2. Ouch. I put this here. A2, B2. So we have it like that. So how do you add vectors? So you make a parallelogram and you just extend this parallel to this one and make the parallel to this one over here. Sorry. And sorry, my second kid is sick too, so I have my cell phone on. So this is the sum of the two. So that's the sum of 2 vectors, right? And that's what we said over here. This is, let's call this one, you just call it U. Let's call this B. So this is u plus b. This is u, this is b. Okay? And that's what we were saying over here. So, of course, you can have more dimensions. Here you just say Rn because you can have U2, U3, U4, Un. So you have three main, let's say you have U1, U2, sorry, A1, AB2, AB1, B2, C2, let's say. A1, B1, C1, and you have A2, B2, C2, and let's say you have another point, A3, B3, C3. So in this case, you are in 3 dimensions. So you have to go one. So you have front and front. So on this one, so first point is A1. So let's say this is, how do we do? Let's say this is X, Y, and Z. X, Y, and Z. So this is A1. So this is B1. So what do? You make a rectangle on the base. And you go up C1. So it'll be here. So you measure C, right? C1. So that's your vector. So your vector should be this one. Okay. And now you do the same thing for A2, B2, C2. So I don't know. Let's say this is A2. Oh, but I said X. Oh, sorry. It depends. People change it all the time, so I can depends which you can put it either way. I put it on. So let's say this is X. This is A2. Let's say this is B2. And you make a rectangle. And then you go up. And this is C2. So you have your other vector here. So cricket. Okay, is 2. Okay. So now you can add the two of those vectors in 3 dimensions. What do? The same thing. You make a parallelogram. And when you obtain, you get your third vector. And this will be, let's say this is your U. And then this is your P. And then this is your W. But I'm not gonna make W. So that's how you make vectors. But you see, when I do it on 3 dimensions, it's kind of not pretty. But you have to see the process, right? So yeah, ouch. And let's make it the red better. And as those are the two vectors, and when you add them, so it's gonna be this one. So your instruction from previous dimensions help you for the other dimensions. Okay. Okay, so that's something is not on the slides. So here they're saying in general, all these, you can go as 3, 4, 5, of course, but you cannot graph it. Okay, so I'm going until I can graph it. And that's how you add vectors. So for example, if I have 5, 3 plus 4, 8, what I do is add turn by turn. That's 11 and 11. And no, sorry, 9 and 11, right? So, and you can verify. It's gonna be the what as we plan. It'll be 1, 2, 3, 4, 5. 1, 2, 3. So this is the first one. And let's make a prediction. So and the other one is 4, 8. 1, 2, 3, 4. And then oh shoot. 3, 4, 5, 6, 7, 8. So 4, 8 is somewhere here. So I had to do the parallelogram. So this is parallel to when this is goes like this, and then they go like it has to be really precise. That right. If I have a really good paper, oh, next time I'm gonna use quadricular paper. And don't make me change that now because I'm gonna get lost. So I'm gonna start using the other kind of paper so I can have better background. So, but you see, it's saying if I can counting, this is 1, 2, 3, 4, 5. Oh, 6, 7, 8, 9. Yeah, it's gonna 9 is kind of here. So you see 9, and then if I can counting, this 8, and to go 9, 10, 11, kind of match, right? So it's the intuition works. But you know, the nice thing is you just add turn by turn. Okay. And the other property is that you can make vectors longer or shorter. So for example, if I have 1, 2 and multiply times 3, this is 3, 6. And if I wanted to make it smaller, 1/2 of 1, 2, oops. Is 1/2, 1. So it means if I have a vector 1, 1, 2, this one, and I multiply times 3, that means I had to be, instead of 1, I had to do 2, 3. Instead of 2, it's gonna be 3, 4, 5, 6. But if I just have to copy this, the idea is that I just have to copy this guy 3 times. Trunk. And that should do it. You see? It should give me exactly the same size. Okay? So those are the operations. And you know, if this is minus, the 1/2 is gonna go to the other direction, but then be shorter 1/2. So will be until here. So that's the interesting thing of this. So there is a lot of geometry here. Okay, that's why people use it, and that's why people like it. Let me see. Where are we? Yeah. So these are properties of vectors. Okay. They look kind of silly, but they are not. Okay, because these are going to be properties we want. So for example, the A says is the same thing that change the order of the sum. That's good. Now you can distribution. That's the distribution we like to do when we eliminate parentheses in real numbers. So all this is coming from the real numbers. A plus B times U can be also distributed like that. But notice, this is the really important thing. So it's probably, let me change it to real examples. Let me go to my other computer so I don't have to copy this all the time. And I can see the slides in my other computer. So we go here. Yeah, okay. So so property A says U plus B equals B plus U. What does it mean? It means like 3, 5 plus 2, 6. It is in the 2, 6 plus 3, 5 is the same. Yeah, that's no big deal. But the other one is a little bit more interesting. A U plus B equals AU plus AB. So this is a big difference between writing mathematics and reading mathematics. Because if you saw it on the computer, well, okay, let me ask you right now. So think 30 seconds. What is the difference between A and U and B? What is the difference? Are they just the same things? Write me an example of this property to see you are really understanding. So UB is 3, 5. Sorry, U is 3, 5, B is 2, 6. What is A? So give me an example of A. Choose your favorite A. So A has to be what? A number. So A has to be a scalar. That's a fancy way to say number, no vector. So in my class, we should use this notation. U, V, V, U. To say these are vectors. And this guy is a vector? No, because it doesn't have an arrow. So vectors have arrows. Numbers doesn't have arrows. Okay? So we have, let's say A is 7. So 7, 3, 5, plus 2, 6. So this is 7, 3, 5. plus 7 to 6. By the way, is this true? So this is how you test it. It's probably something you are not understanding and you haven't asked because we are online. So that's what I'm gonna have online. Oh, it's gonna like the classes online, but we're gonna have opportunities for all you to be present Monday, Wednesday, Friday. So you can ask questions. So here, for this side, let's say the right-hand side. So I need to operate this. How do I operate this? This is 7 times 3 is 21. 7 times 5 is 35. Plus 7 times 2 is 14. 7 times 6 is 42. Okay. And then, because this is my operations, that's how I operate a number times a vector. Because it was one on the properties. Remember when we saw it here? This property. Scalar multiplication, addition, and when two vectors are equal. Those are the rules, guys. So when you are starting playing a board game, those are the rules. If you don't apply these rules, you are not playing the game. So we are applying the game. So here, now I can add, that's 21 plus 14 is 35. Now 35 plus 42 is 90, no, 70, 27. Yeah. So now on the other hand, here, first I need to make my sum. So I have 7, 3 plus 2 is 5, 5 plus 6 is 11. So I get 7 times 5 is 35, 7 times 11 is 77. Look at, I got the same. So what it's saying is, at least in mathematics, you can first, what do you say? Let's say A is putting the salt to the egg, okay? So you can first put 1 egg and 2 eggs in the fry, they put the salt. Or you can put first, and then either, right? So first you can make your first egg, put the salt, then make the other egg, put the salt, and eat both of them. So it's like you at the end your stomach is equally full. We're not talking about satisfaction. Okay, so this is not cooking, this is math. So, but what we're saying here is at the end, whatever we're measuring is the same number. Okay, so that's an important rule. The other important rule is A plus B, a U vector, AU vector plus BU vector. So when I'm grading your quizzes or your exams, I will see if you're watching my videos or not, because this is gonna tell me, huh? Smart, huh? I'm gonna see if you're watching my videos. Okay, so you don't make the arrows, you're gonna make mistakes. So this is another property, but this time is the sum of two numbers times vector. So you can make the sum of the two numbers and multiply the vector, or multiply the first number times the vector, or the second number times the vector. So let's do it. So 3 plus 5 and 1, 2. And the other is, here is 3, 1, 2 plus 5, 1, 2, right? So 3 plus 5, 7. 1, 2, and this is, well, let's finish it. This side. So 7 times 1 is 7. 7 times 2 is 14. Here we need to do 3 times 1, 3. 3 times 2 is 6. Plus 5, 10. And then 6. I make a mistake. 3 plus 5 is 8, kid. Sorry. 8. And then 16. And the 6. Oh, my goodness. I'm sick, guys. Let me have it. 8 and 16. Okay. That works, right? Okay. The so U plus B plus W equals U plus B plus W. Well, I think I'm better than I thought because I thought I would be copying all this time. So this is similar. So you get and now you can verify this. 1, 2 plus 3, 4 plus 5, 6 equals 1, 2 plus 3, 4 plus 5, 6. So you add these vectors first. So let's do it super fast. This is 1 plus 3 is 4, 2 plus 4 is 6, plus 5 plus 6. That will give me 9, 12. And if I do it this way, I first need to find 3 plus 5 is 8, 6 plus 4 is 10. And then this is 9 and 12. Okay. Okay, so and so on. So just let me finish saying, because all these are very important. You have to do a homework about this, of these vector properties, algebra property vectors. And they're not going to be that easy as these ones. Okay. So let's make E says one number, or one scalar times another scalar times one vector is the same that the two numbers times the vector. So let's say it's 3, 2, 1, 2. And then this is 3 times 2, 1, 2. So it gives me the same, yes. 3, 2, 4, and 6, 1, 2. And I get 6, 12. This 6, 12. Okay. So, and then another property is that there is an inverse. This vector plus minus the inverse additive of that one give me the zero vector. Example 1, 2 plus, and I'm gonna put minus 1, minus 2. It gives me 1 minus 1, 2 minus 2, that's 0, 0. Right? Now G says U plus a zero vector equals 0 plus the U vector. And this is just the same vector. And that is trivial. And finally, there is the number 1 times the vector is the same vector. Okay, so I think I can stop here for today. And I'm gonna make the other part of this video on Friday, on my Friday class. So you guys can continue. However, the homework is gonna be open today, so you can start playing with these properties. The next class, I'm gonna start with linear combination of systems. Basically, we're gonna do this. So you can take a look to the slides to prepare. And this is, well, I already did geometry vectors, no? Oh, well, I have to do the difference. Okay, let's do difference because I didn't do difference. And then the span, that's next class. Let me give you some time to warm up because you need still time to warm up. Span is just we're starting the real stuff. So this is also vectors in R3. It's also how do you span it. But so we'll talk about this on Friday. So let me give you a last chance to catch up. Okay. So what I want to say about vectors, subtraction vectors. Let's say we have difference of vectors, u minus b. Okay. So let's say u equals phi 3. And b, let's make it minus 2 minus 4. No. Let's do 2, 4. So let's do, so u is phi 3. So 1, 2, 3, 4, 5. U is 3. 1, 2, 3. So 1, 2, 3, 5 is here. Then I get b is 2. And then 4. So over here. So now the difference, so we do u minus v. So I write phi 3 minus 2, 4. And this is 5 minus 2 is 3. And 3 minus 4 is minus 1. So I need to go the 1, 2, 3, and then minus 1. So this is the difference. Okay. And this is u minus b. If you want to represent it geometrically, so it's probably this guy here, and oh yeah. So do you guys see it? So when you make the geometric difference, is this guy over here. But since this is vector spaces, all your vectors need to start over here, like arrows. Okay. Of course, in physics, you move the arrows, the vectors, and displacement like that, right? So basically, this vector and this vector are the equivalent, are the same. Because this doesn't make sense, a vector doesn't make sense in R2. In R2, all the vectors are born here. So these two guys are the same guy. Okay. So when we're talking about the R2 space, this guy doesn't live in the R2 space because he's not born here. Okay. That's something important. That's something that even if you read the whole book, I think unless you do the problems from the book, you're gonna have a hard time. Although, but you can try to solve the problems of the book, but if you don't, nobody's correcting them, so you might not know what is going on, what is not getting right. Okay. Okay, let me stop here. And I'm gonna open some homework so you can start having fun with the new part. 22. We'll stop soon. Yeah. Okay. Okay. Thank you guys. Not sure how long we recorded. Let me see.